Hi, I'm Adolph Oliver, and this is a video clip on complex rational expressions. Now, the first thing you want to remember is this term rational has the word ratio in it to begin with, and ratio means that you can write it as a fraction. Complex rational expressions are fractions that have other fractions in them. Here's a simple example. 1/2 divided by 1/4. This is basic math. There are no variables here, but we'll look at some variables in a few minutes. But now, think of it this way. You could have 1/2 ounce of perfume, and you might be wanting to figure out how many 1/4 ounce bottles you want to fill up. Well, you can figure this one out pretty easy. The first 1/4 ounce bottle you fill from the 1/2 ounce you have uses half of it up, and you have a 1/4 ounce left. So that means you can fill a second 1/4 ounce bottle. And so we can tell from this, very simple, that you get 2 bottles, okay, which are 1/4 ounce each. Okay, well, this is the same as we've talked about division in the past. You can think of division as just repeated subtraction. How many times this guy in the bottom can be subtracted from the top. And of course, we can subtract 1/4 from 1/2 twice. Well, here's the key. Any complex rational expression like this, a fraction that has other fractions, can always be simplified to a single fraction with no other fractions in it. Final answers with fractions should always be simplified in this way. Now, there are different methods to simplify complex fractions. I'm going to show you one of them. That's the reciprocal method. And it's based on 2 math facts that makes it work. One is, if you have a number like 6/1, well, that just equals 6. You can toss the 1 away downstairs because how many times can you subtract 1 from 6? Well, 6 times. The second thing is a number multiplied by its reciprocal. Let's say 1/6 times 6/1 equals 1. That's, of course, what reciprocals do. Now, let's revisit our original problem that we had up above here and show you now how this method can be used to be able to solve this. Okay, here we go. We had 1/2, okay, and underneath it in the denominator 1/4. Well, here's what we're going to do. If I can change this downstairs to 1, what that means then is the answer just the upstairs. Well, what can I multiply 1/4 by to change it into 1? I can multiply it by its reciprocal. So if I multiply the downstairs by 4/1, that's the reciprocal of the downstairs, this will cross cancel, of course, and end up giving me 1 over here. So here it is, the 4's cross cancel. We get 1. Well, now, I don't want to change the answer to this problem. So here's what we do. If I multiply the bottom of the fraction by 1/4, I've got to multiply the top by the same thing. And it's not 1/4, it's 4/1, the reciprocal, and I'm multiplying it by. Notice now, if I'm multiplying the top by 4/1 and the bottom by 4/1, 4/1 over 4/1, the numerator and denominators are the same, so it equals 1. Well, you never change the value of anything when you multiply it by 1. You can change what it looks like, but not its value. Well, okay, let's see what we got on top. 2 cross cancels into 4 twice, so I end up with 2/1. Well, of course, we know that a 1 downstairs in a fraction just means the answer is the numerator. So here I have 2 over the 1 that's downstairs here. And of course, the 1 downstairs just means the answer is the numerator. So there it is. There's the 2 that we figured out on our own up above. Okay, well, this is the general idea. Now let's take a look at some problems that have some letters in them. Okay, here we go here. Here's the next one we're going to look at. And notice now what we have here is a single fraction upstairs and a single fraction downstairs in this. So this is definitely a complex rational expression. Now, notice the nice thing is, since this is a single fraction and this is a single fraction, we can just jump to the reciprocal business right quick here. So what we saw is the name of the game is to multiply both top and bottom by the reciprocal of the bottom. So let's see if I can do this correctly. Okay, the reciprocal of 9 over u is u over 9. And I have to do the same thing up above, u over 9. So now remember, u over 9 times u over 9 right here, this equals 1. So as we pointed out to you earlier, we're really just multiplying this original number by 1, which means we're not changing its value, but we want to change what it looks like. Well, downstairs, everything cross cancels. And of course, we end up with the 1 down there. Upstairs here, let's see what we can do. Nothing cross cancels here. So it looks like we're going to end up with u squared times u, which is u cubed, all over 4 times 9, which is 36. Well, the downstairs of the big fraction here is 1. And so that means the answer is just the upstairs. So here we are. Our final answer is u cubed over 36. So we've been able to take this original fraction over here and write it in a more simplified form right here. Okay, well, now let's look at something where we have to do a little bit more work to be able to get our answer here. Here we go. This is definitely one of these complex fractions again. One big fraction, but we've got other fractions in it. Well, the upstairs is real easy to make a fraction out of. Here's our main fraction bar right here. I can always make a fraction out of anybody by putting a 1 underneath. So let's do that. Here it is. And so a over 1 is the same as a. Downstairs now, we got a little bit of work to do. We got to combine these two guys. They're being added into a single fraction. Well, you can't add or subtract fractions unless you have a common denominator. And we're off a little bit here. Okay, this is a and this is a squared. The LCD is a squared. So what I've got to do here is multiply this first guy over here by a over a. Why am I doing that? Well, I want to multiply the bottom by a to get this LCD equals a squared, but I also have to multiply the top again by the same thing. Okay, so what do we end up with? Well, I have a over a squared. Okay, here we go. Plus b squared over a squared. Here it is. Okay, well, we have a common denominator here now. So that means, let me write it right down here, that I can now write the bottom as a single fraction. Let's not forget the top. We had that as a over 1. Here it is. Okay, well, I've got the common denominator a squared downstairs. Okay, what's the numerator going to be? Well, a plus b squared. Here it is. Okay, now, here we go. Once we got a single fraction top and bottom, and notice we had to do a little more work this time. The top was real easy to make a single fraction out of. It was basically there already. The downstairs, however, we had to do a little add and subtract business with fractions. But now we're set. Now, let's make another jump here. I know if I multiply the bottom by its reciprocal, which is a squared over a plus b squared, this is going to give me 1, isn't it? It'll cross cancel. So let's save ourselves the trouble. We know that's going to happen. Let's just go up here and just multiply the top. But now make sure that you do the reciprocal. Here it is, a plus b squared. Now, what we've done here is we could have written the a plus b, a squared over a plus b squared, the reciprocal downstairs here, and these guys would have cross canceled. But, you know, we know that's always going to happen, so let's just go for the answer, and that's what we're doing here. Now, here we go. what we got to do to be able to come up with the answer, the downstairs, of course, we know is going to equal 1. So let's start setting that up a little bit further here. Here we go. The downstairs is going to equal 1. That's because this thing times the reciprocal, which we didn't do, we know is going to give us 1. Upstairs, I've got a over 1, okay, times a squared. Here it is. This guy here is multiplying this guy. A squared. Now, you have to factor these if you can to see if you can reduce anything. And notice the downstairs here, the a plus b squared does not have a common factor. So the only thing we can do to make a single term out of it is put parents around it. So here we go. These are all the guys that are multiplying each other. We can't cross cancel here because the a is not the same as this quantity a plus b squared. So here comes our final answer on this. Okay, let's write it out here. And the final answer then, we got a 1 downstairs, so we don't need to write it. The answer is just the upstairs. Nothing to cross cancel. So we have a cubed, a times a squared, and of course the a plus b squared did not get canceled out any, so there it is. Now, I like to leave anybody that's more than a single term, like this guy right here, in its factored form. And remember, by factoring, we have to reduce it to a single term. And since there was nothing common, the only way we could make a single term was put parents around it to indicate that we're taking the whole thing all together as one term. Now, if you were to drop the parents here, you might do something bad. You might try and cancel this a against that a cubed. Well, that doesn't work then, because if you drop the parents, you no longer have a single term. And remember, to be able to reduce fractions, you always have to have a single term upstairs and a single term downstairs. So that's why I like to keep the parents around here, just to remind you that, hey, you can't go any further, that's it. Okay, well now, let's look at another one here that's kind of like this. We have to do a little bit more work because that's the normal thing that happens on all of this stuff. Okay, once again here, a complex fraction. We got one big fraction, but the upstairs has more than one other fraction in it. And there's, of course, a fraction downstairs too. So now this guy has fractions and fractions. Well, okay, what we got to do is add these guys together upstairs. Again, we're given a gift downstairs. There's only a single fraction here. So let's see, what's the LCD going to be upstairs? Looks like it's going to be XY. So that means I'm going to have to multiply this first guy by X top and bottom to make XY in the bottom. And the second guy by Y top and bottom. Now, if I do that, then what I have, of course, the 2 over x squared remains that way downstairs. But now, up above, I'm going to have x times x squared, which is going to give me x cubed, but now over xy. And then I have plus y times y squared, which is y cubed, all over xy. Now remember, don't reduce these guys back down again. We wanted them to have a common denominator here so we could turn around and add them. That was our goal here of what we're doing. Okay, well now let's take a look at our next step here. We're going to then combine the top, since we have a common denominator. It's going to be x cubed plus y cubed. Here we go. X cubed plus y cubed all over the common xy. Okay, downstairs we have 2 over x squared. Okay, well now we got a single fraction upstairs, single fraction downstairs. Now it's time to play the reciprocal trick to be able to simplify it all the way. Again, I'm going to multiply the top and bottom by the reciprocal of the bottom. Well, that's x squared over 2, and if we do it downstairs, it's going to give us 1. We know that. So I say, okay, let's just shortcut this. I'll just take this guy upstairs, make sure you write him as a reciprocal the way he should be. So here we go, and our next step in working on this. Okay, here it is. Again, upstairs, we've got the x cubed plus y cubed all over xy. Okay, there it is. Times now the x squared over 2. Remember, we had to make sure we did the reciprocal on this, so here it is. Okay, and of course, the reciprocal down the bottom here, multiplying by that, would have given us the 1, so we'll just put it in here to make note of that. Okay, now, upstairs here, we have to factor all the numerators and denominators. Everybody's a single term here except for this cube guy. So here we go. The only thing to do for him is put him in parents, so we'll do that. X cubed plus y cubed. Okay. Downstairs we have the xy. Remember, I'm just looking at the numerator. The denominator is 1. And over here, the second guy where we're multiplying this, we got x squared, and then downstairs times 2. Well, there is a little something that we can cross cancel here. Okay, here it comes. We can cross cancel an x. So x goes once here, and an x squared leaves me a single x. So my final answer here on this, the 2 doesn't cross cancel anything, so I have x times x cubed plus 3y, here it is. Okay, and downstairs 2 times 1, which is 2. Now, you could multiply this out, but I like to keep it in factored form like this just to remind you that if you want to do any more cross-canceling, you'd have to, reducing, you'd have to make sure everybody was factored completely, and here we go with these guys. So there it is. Now notice, what we were able to do was to take our original fraction, this guy up here, more complicated, simplify him down here to a fraction that had no other fractions in them. And that's that simplification process that we're doing once again. Okay, let's look at one last example here of these guys. One where we've got to clean up both the top and the bottom. Okay, and this is not uncommon. Notice that I've got 2 fractions upstairs. The LCD is 5y, so that means I'm going to have to multiply this first guy, top and bottom, by y. And that'll give me then upstairs x squared y over 5y minus y squared over 5y. Okay. Downstairs, okay, I've got to do some cleaning up too, so let's do that as we go along. Looks about the same idea here. The LCD is 5y, so that means I've got to multiply top and bottom of this first guy by y over y. So I end up downstairs with y times x squared. I'll put the x in front, you can do it either way, over 5y plus y squared over 5y. Okay, well now let's see what we can do further with this. Okay, here we go. We still have to get the top and bottom to single fractions each before we can do our reciprocal method. But we have a common denominator now in both of these, so we can make some headway. Upstairs, I've got x squared y minus y squared down, and the denominator for all of this, 5y. So all I've done is I've got a common denominator here. I've just added or subtracted the numerators. In this case, it was subtraction. X squared y minus y squared. Downstairs, similar idea going on here. What's going to happen now is I've got, again, x squared y, but now plus y squared, again, all over 5y. Okay, well, now we're all set to be able to do our reciprocal trick because we have a single fraction upstairs, single fraction downstairs. Once again, I'm not going to rewrite the reciprocal down here because I know it's going to cross cancel to give me 1. Now let's just concentrate on the upstairs, which is going to be the answer. I'm not even going to write the 1 down here because I know a 1 down below means the answer is what's upstairs. So here we go. Let's work this upstairs guy. Here it comes. So what we've got is x squared y minus y squared all over 5y. Now we're going to multiply this whole guy by the reciprocal of this. Make sure, of course, that you reciprocate it. Here we go. So x squared y plus y squared. Okay, so here it is. Now, again, before we can do any cross-canceling here, any of these guys that are more than single terms, we've got to factor them. And notice there's a common y up here in this first guy. So I can write this as y times x squared minus y. Okay, that's my top up here, all over, of course, 5y. And then the next guy here, we, of course, have got the 5y upstairs. Here it is, all over. Well, there's a common y down here. I can cancel, factor out. Here it is, y, and I got x squared plus y. Okay, now let's double check this. Multiply this back. Y times x squared would be x squared y. Remember, you can write them in either order. Y times negative y squared. So it looks like we did that correct. Downstairs here, y times x squared. That can be written as x squared y plus y times y squared. That looks good. Okay, well, notice now, we got everything factored here to single terms. There's some things we can cross cancel here. The 5y goes once here and cancels against this guy. The common y's cancel against each other. There they go. So what we end up with for our final answer here, let's write it down. Here it comes. Okay, upstairs we're going to have x squared minus y, and downstairs we're going to have x squared plus y. Okay, well, these guys are not exactly alike, so we can't do any further reducing. This one has a minus, this one has a plus. That makes them quite different from each other. But there we are. This is what our original fraction ends up simplifying to. Remember, it was, a lot more involved up here. Okay, but it turns out that we can simplify it and write it as this guy right here. Okay, well, there we go. That's how we handle these complex rational expressions.